Hi friends, in this video we are going to discuss about the concept of impedance parameters, or we can also call it Z parameters, or we can also call it as open circuit parameters. So why we are calling as open circuit parameters means by opening the port 1 you will get 2 parameters, and by opening the port 2 you will get another 2 parameters. So that is the reason why we are calling as open circuit parameters. It means when we are going to opening port 1 and port 2, so you are going to get the parameter. That is the reason why we are calling as open circuit parameters. Now our question is to find the Z parameter. Z parameters means what? So total how many Z parameters are there? So totally, so Z11, Z12, Z21 and Z22. So we are having totally 4 individual parameters are there. Here out of these 4 individual parameters, so Z11 and Z22 are called as self impedance parameters, self impedance parameters, because Z11 is connected to only port 1, Z22 is connected to only port 2. But coming to the remaining parameters Z12 and Z21, so these 2 parameters we are calling as mutual impedance parameters. Because why we are calling as mutual impedance parameters means, so these 2 parameters are going to connect between the port 1 and port 2. So if you are going to represent all these parameter with the network, so the network like this. Now for example, see, so this one is we are calling as Z11, and coming to this one I am giving the name for this one is Z22, and here we are having the port 1 voltage source, and here we are having the port 2 voltage source. Okay, now current coming from the port 2 is I2, current coming from the port 1 is I1, and from this between these 2 ports we are having another impedance, that is Z. Now Z11 is the self impedance parameter for port 1, Z22 is the self impedance parameter for port 2. But coming to Z12 means when we are going to write the expression loop 1 in terms of loop 2, then you are going to consider the impedance parameter as Z12. And coming to the another loop, that is second loop. Now if you are going to write in the expression loop 2 in terms of loop 1, we are going to take the impedance as Z21. It means this particular Z12 and Z21 are the mutual impedance parameter which are connected between the 2 individual ports. Okay, for example, see here, if I am going to consider this is the loop 1 for example, and the current flowing in the loop 1 is I1. Now coming to here, this is I assume this is loop 2, then current flowing in the this particular second loop is what? I2. Now our target is to find the values of what? All these parameters. So how much value of impedance parameters? So those are Z11. What is the value of Z11? What is the value of Z12? And what is the value of Z21, and also what is the value of Z22. Now our target is to find all these impedance parameters. So how we are going to get all these impedance parameters from any network? So this is our question. Now in order to get all these parameters, so what are the changes we need to do in the circuit to get all these things? Okay, now coming to the most important concept, that is what? Getting the impedance parameter with the help of the short circuit conditions. Okay, now here how to get impedance parameters, how to get impedance parameter from the given network. So this is our question. Okay, now in order to get all these parameters, for example, what I am doing, just I am going to considering this particular network. So just see here, for example, I am going to consider this one as same Z11. So this one is Z22, and here this one is we are calling as, for example, Z, which is the mutual impedance connected between the port 1 and port 2. So here this is plus, this is minus, current I1 is flowing, and this one is current I2, and this is plus, this is minus, and this one is the voltage across port 2, and this one is the voltage across port 1 we are applying. Okay, now this is the mutual impedance connected between these two. Okay, now our target is to find all these parameters. Okay, now here I1, I2 are the independent variables in the two-port networks. Okay, I1, I2 are the independent variables. But here coming to the V1 and V2 are the dependent variables. Okay, now the relation between this I1, I2 and V1, V2, we are going to get the expression of impedance parameters. So we can also call it as standard expressions. Okay, so standard expressions. So standard expressions of Z parameters are given by now V1 is equal to Z11 into I1 plus Z12 into I2. Now V2 is equal to Z21 I1 plus Z22 I2. Now assume this is equation number 1 and assume this is equation number 2. Okay, now coming to observe this point, Z11, Z12, Z21, Z22. These are the parameters we need to get from these particular standard expression. So when we are going to get Z11 and Z21, so if we want to get the Z11 and Z21, what you need to do? So just you need to open circuit port number 2. Okay, if you are going to opening the port 2, then if you are opening port means there is no flow of current I2 will flows, because in case of open circuit current is 0. That is the reason why if you are opening the port 2 means I2 is equal to 0. Okay, so that is the reason why, see here, to get Z11 and Z21 parameters, so to get Z11 and Z21 parameters, simply open circuit port 2. That is, if you are opening port 2 means the value of I2 is equal to 0. Okay, now use this expression, use this condition and substitute in equation number 1 and 2. Okay, if you are going to substituting this I2 is equal to 0 in equation number 1 and 2, then you will get, so V1 is equal to Z11 I1 plus Z12 into, instead of I2 I am placing directly 0. Okay, now here coming to simplify, just V1 is equal to Z11 into I1. Now this value 0 into something 0, then finally you will get what? So V1 is equal to Z11 I1. Now from this expression we can write Z11 is equal to V1 divided by I1. Okay, so this is always in ohms. The unit of impedance is always in ohms. Now this is the parameter Z11. Now this particular Z11 we can also called as, so this particular Z11 we are calling as open circuit driving point input impedance. Okay, so we are calling as Z11 is open circuit driving point open circuit driving point input impedance. Okay, so anyway, finally we got the value of self impedance Z11. We can also call as Z11, we can also call as open circuit driving point input impedance. So finally from equation number 1, we got the value of Z11 parameter. Now coming to the second one, that is what? So from equation number 2, if suppose we are going to substituting the value of I2 in equation number 2, then from equation number 2, so V2 is equal to Z21 I1 plus Z22 I2. Now we are simply substituting the value of I2 is equal to 0. Then V2 is equal to Z21 I1 plus Z22 into I2 value 0. Now V2 is equal to, so Z21 into I1, so this is 0. Now V2 is equal to, so Z21 into I1. So from this expression we can write, so Z21 is equal to V2 divided by I1. Okay, and this is always in ohms. Okay, so now Z21 is a mutual impedance which is connected between the port 1 and port 2. Now Z21 we can also called as, so if you want to define, or if you want to call this Z21 as in another way, that is we can call as open circuit forward transfer impedance. Okay, so we can call as open circuit forward transfer impedance. So Z21 is called as open circuit forward transfer impedance. Okay, so finally by opening the port 2, finally you got the two parameters, those are Z11 and Z21. So just see here, I am going to draw the circuit like this. Just see, so this is Z11 and here we are applying, so V1, and we know that we are applying the condition, that is port 2 is open. Port 2 is open means simply we do not have any voltage and we do not have any current which is flowing. It means the current flowing in or current coming from the port 2 is 0. Okay, now this is a Z. Okay, now this one is a V, and current flowing from the source V1 is I1. Now we can call as this one is mutual impedance and this is the Z11 self impedance. Okay, now this part, this particular part we are open circuited. Okay, so because of open circuiting of port 2, finally we got the Z21 is equal to V2 by I1. We are calling as open circuit forward transfer impedance, and Z11 is equal to V1 by I1. We are calling as open circuit driving point input impedance. Now anyway, finally by opening port 2 we got two parameters, Z11 and Z21. Now coming to the calculation of remaining two parameters. Okay, so here to get Z12 and Z22, so to get Z12 and Z22, just simply open circuit port 1, open circuit port 1. So if we are opening the port 1 means the current flowing in the port 1 I1 is equal to 0. Okay, now substitute these I1 is equal to 0 in equation number 1 and 2, then you will get the remaining two parameters. Okay, so now to get the value of Z12 and Z22, so here we need to get the value of remaining two parameters, those are Z12 and Z22. So to get this Z12 and Z22, what we need to do, simply open circuit port 1. So if you are open circuiting port 1 means the value of I1 is equal to 0. Okay, now just see here, if I am going to open circuiting port 1 means the diagram or the network will becomes like this. Just see here, so here the V2 is acting, and here this is the mutual impedance connected between the two ports, and this one is open circuited. It means this one is open circuited. If you are open circuiting the port 1 means I1 is equal to 0, but this I2 is flowing in the circuit. Okay, now substitute the value of I1 is equal to 0 in the expression of 1 and 2. Okay, if you are going to substitute the value of I1 is equal to 0 in equation number 1 and 2, then you will get, just see here, so the standard equation from equation number 1 we can say that V1 is equal to Z11 I1 plus Z12 I2, and from this we can say that V1 is equal to Z11. So we are open circuiting the port 1. Open circuiting the port 1 means the value of I1 is 0. So that is the reason why instead of I1 we are simply substituting the value of 0 and remaining terms Z12 and so Z12 into I2. Now V1 is equal to 0 into something 0, and the remaining terms Z12 into I2. Now from this expression we can say that Z12 is equal to V1 divided by I2, and this is always in ohms. Now this particular Z12 is the mutual impedance connected between the two nodes. Now we can also call it as Z12, we can also call it as open circuit reverse transfer impedance. So we can simply call as open circuited, so open circuited reverse transfer impedance, so we can call as, so open circuited reverse transfer impedance is Z12. Now finally we got the parameter of Z12 by substituting the value of I1 is equal to 0, because this I1 is a current which is supplied from the port 1, but we know that open circuiting port 1 means I1 is 0. Simply we are substituting the value of I1 is equal to 0, and finally we got the Z12 parameter as V1 by I2. Okay, now coming to the equation number 2. Now substitute in equation number 2 I1 is equal to 0, that is V2 is equal to Z21 I1 plus Z22 I2. Now V2 is equal to Z21 into I1 value 0 plus Z22 I2. Now here V2 is equal to 0 into something 0. Now the remaining term is Z22 into I2. Now from this expression we can write Z22 is equal to V2 divided by I2, and this is in ohms. Now units of impedance is always in ohms. Now this is a self impedance parameter for port 2, and we can also call as Z22, we can also call as open circuit driving point output impedance. So open circuit driving point output impedance. Okay, so output impedance, clear? So finally we got the impedance Z22 is equal to V2 by I2, we are calling as open circuit driving point output impedance. Z12 is equal to V1 by I2, open circuited reverse transfer impedance. And coming to, so Z21 we are calling as open circuit forward transfer impedance, and here the value of Z11, that is open circuited driving point input impedance. So like this we need to get the impedance parameter from any two-port network. By open circuiting port 1 you will get 2 parameters, by open circuiting port 2 you will get another 2 parameters. So like this we need to find the impedance parameter from any two-port network. So thank you so much for watching, and please do subscribe my channel. Thank you.